Salam and good day. So we are going to look at the programming wise in Matlab, how we can do the Fourier transform, which is we're going to do the special domain to the frequency domain. So on the first step, you're going to just read the image that you want to do the transform. So just get any image that you want, and you're going to read the image. Okay, so this is the first one. So we're going to use the imRead function. So this is my image. I have put it down over here. So then to make sure that we have the image right, so we can do the subplot command to display the image. So this is based on the subplot command. So this is the reading the image, and we can going to show the image title with this one. Right? So just run this one, and you can see that the image original is this one. This is the Ruby image. Okay, the next one, we're going to convert this RGB image to grayscale image. So let's do it. So we're going to convert the image right here, convert to RGB by using the function here, RGB to gray image, convert the RGB to grayscale. All right, so we are going to have this eye over here. Then we're going to subplot the eye and look at the results again on the same subplot over here. Just run this one, and then you can see the results. You have the original image, and then you have the grayscale image. And then we are going to start to do the Fourier transform by using the library from Matlab. So to use the library is very simple. You just need to use this command. All right, for Fourier transform conversion, we are going to use the fast Fourier transform. This is for 2 dimension, which is our fxy, and then this is the image from the grayscale here, and the output will be coming in J over here. So we're going to do the subplot for the third one after the Fourier transform. Right, this is the third one, so we're going to run this one, and you can see the results for the third one. This is your Fourier transform. Basically, you cannot see in terms of visualization. This is just like a salt and pepper notch, right? So this is not really can be visualized. I mean, this is very hard to visualize that you had changed it to the frequency domain. So what we are going to do here, okay, we are going to use the log to what we call that. We are going to the let's look at the command here. All right, so we are going to log the real value from the Fourier transform to get the absolute value for the magnitude. All right, so we are going to use the log. Why we're going to use the log? Because we are going to give a better visualization, because the log will take the white value and compress it down. All right, so I'm going to put the comment over here. All right, so the absolute value is to get the real value part, the real part of the Fourier transform. Why we need to do the log value? Because we'll give a better visualization, and the log, what happens here, the log will take the white value, all right, and compress it down. So this is the result after you do the log. Okay, so we're going to plot it right here. So you're going to do the after log visualization. So we just run this one, and then we're going to look at the results here. You can see that from this one Fourier transform, after you do the log conversion, not log conversion, this is after the log process, you are going to get this particular image. So here you can see the image, the concentration is actually at this particular angle here, this 4 area here. So this is not normally can be seen, because we want to make sure that the low frequency is getting at the center here. So what we have to do is we have to shift, okay, we have to shift the Fourier transform to make sure that the low frequency will be at the center of the image. So what we should do is we can do the command shift of the image here. All right, here a shift, this is a fast Fourier transform shift from this one. After you log, then you shift it. So then you plot again the image, right? right? C, and then we just run this one. Then you can see the results here. The image now, you can see this is like what we saw in the lecture. So all the low frequency is at the center here. All right, so this is actually the output from the pulse Fourier transform after you shift it out. So they just want to give a comment here. All right, so the low frequency will be at the center here. So this is why in the presentation slides, right, in the presentation of the YouTube, you are looking at the very, very clear output for the Fourier transform. All right, you have a try, and you can you need to answer the quiz after you try all this. All right, thank you very much on this one.